Hi, everyone, and thank you for joining today's live stream. Today, HashiCorp co-founder and CTO Armon Dadgar will walk through what's new in 1.4, and Justin Weissig, technical product marketing for Vault, will do a technical deep dive and demonstration of the new features. We will then spend the last 20 minutes of the webinar dedicated to a live Q&A. This webinar is recorded, and the recording will be made available after processing, usually within a day or two. We'll email it out to you all. And as we go through the presentation, feel free to put questions in the question box. We will answer them at a Q&A towards the end. With that, we can go ahead and get started. Off to you, Armon.
Thanks, Chris, and thanks everybody for joining us. Today, what we're going to do is talking about Vault and then getting into some of the new features coming with the launch of Vault 1.4. But for folks that are maybe a little bit new to HashiCorp or new to Vault, I wanted to set a little bit of background. So maybe starting with the company, for folks that are not familiar with HashiCorp, our focus is really on cloud infrastructure automation, right? And so I think oftentimes people know us more for our tools than they know us for the company name. And so there's at least 6 major open source projects that we are focused on. That includes Vagrant, Packer, Terraform, Vault, Consul, and Nomad. The company is a little over 8 years old. We're a little north of 900 employees and have raised about 350 total and 350 million in funding in total. So, shifting gears, we have a lot of different product focus areas, but today I want to spend the time talking about Vault. And I think what's been interesting is as we go through this transition to kind of cloud-oriented infrastructure, there's been a major shift in how we think about security in general, right? The kind of principles, the core approaches that we take, the kind of philosophy has been changing. And so I think in many ways, there's, you can kind of capture some of these changes through 3 pillars, right? One is this notion of zero trust, right? How do we move away from devices internally because they were on a private subnet, or we trusted a set of devices because they were on, the corporate fabric, to really this model of trusting nothing, right? That whether you want to call that low trust, zero trust, no trust, it kind of comes in different flavors. Notion that there is no trust as we have, a much more complicated cloud topology, or bring your own devices, or in general, just moving towards a more secure posture. And so I think some of the implications of that zero trust posture means that we need much more encryption of our data, whether that's data at rest. This could be databases that are still behind our firewall, but we're still taking additional protection. It could be data that we're pushing out to the cloud, right? So we might use a cloud service like S3, but how do we layer on additional protection to, in case someone leaks an API access key, making sure that data is additionally protected at rest. And then data in transit. So even as we talk about data moving between our applications and services within our data centers, how do we encrypt that as well, right? So really this notion of default encrypting everywhere, right? And then this kind of security has to extend everywhere, right? Historically, we might have carved out and say there's zones within our private data center that are more secure, we kind of treat as high trust, high confidentiality. But as we extend to maybe over a VPN, that's where we'll put security. I think that notion is going away. And really with this moving towards a model where we want everything secure, don't assume some zones are sort of more privileged or more secure than other zones. So I think there's this sort of expectation in security that these principles are kind of how we approach these problems. So I think in that context is really where Vault sort of plays at least 3 different major use cases, right? The first is secret management, which is how do we actually store secrets? How do we distribute them to our applications? How do we rotate them? So we'll talk a little bit more about what that looks like in a second. The second is data encryption or data protection. How do we actually provide some sort of middleware facility to our developers to help them protect application data, right? So this is almost one level removed. It's what are the APIs, what are the systems that we give our internal development community to say, great, if you're going to protect your data, here's the set of APIs you should be using, right? And then advanced data protection, really looking at as we extend to everywhere and every system, how do you kind of start to plug into things that might be commercial off-the-shelf software, for example, a database or other system that you don't own, but you still want to make sure it's encrypting its data at rest. And so when we talk about Vault, it's a very widely used, widely deployed tool. It's been around since 2014. It does tens of thousands of downloads on a weekly basis. It's trusted by hundreds of the Fortune 2000, and these are just a handful of names who've shared their usage of Vault. So I want to go back to that first use case, which was secret management, right? When we talk about secrets, I think there's often this question of like, well, what are we talking about? What's this domain of, when we say a secret, what's actually under management? And so the language I like to use here is to make a distinction between data that's secret and data that's merely sensitive, right? So a secret is in some sense anything that can be used for authentication, right? Auth-N, or for authorization, auth-Z, right? So classic examples of this might be a username and a password for a database, or a cloud API key, or a TLS certificate. With each of these things, I might use a username and password to authenticate against a database, right? An API key might similarly authenticate and authorize me to read data from S3. A TLS certificate might authorize me as HashiCorp.com, right? And so in this sense, these are hyper-sensitive because they allow me access to another system. That system may then have a bunch of data that I should or should not have access to, right? Versus when we talk about sensitive data, this is anything that you'd like to keep confidential ultimately, right? This could be social security numbers, credit cards, personally identifiable information. And so what's different about this is a social security is something I want to leak, I don't want to lose it, but I can't use it to log to a database. I can't use it to make a cloud API request, right? So in that sense, it doesn't allow me to elevate my permission and authenticate or authorize against a service, right? And so why make a distinction between these two things at all? I think there's one is the sort of severity of leaking one of these things is a lot higher, right? If you potentially lose a database username and password, it's all the data in that system that's now suspect and potentially compromised. But two, the volume of data that you have is very different in these categories. A very large enterprise might have 100,000 to 1 million pieces of secret information, but you could easily have billions to trillions of records that fall in the sensitive category, right? So many, many orders of magnitude different in terms of the scale of each of these problems. And so they require slightly different approaches in terms of how you manage it. They can't be done in kind of a uniform way. You also tend to have much more sensitive data that's fragmented across many different systems. So when we talk about secret management, there's sort of a set of questions that I think kind of guide our thinking, right? These are the questions we'd like to have good answers to within this practice, right? So these tend to be from fairly basic to, for example, how do our applications get access to secrets? Great, I deploy a web server. That web server needs to talk to a database. How does it get a database credential, right? To how do our human operators get access, right? If I'm a DBA and I need to perform an administrative action on that database, how do I get a credential to log in? To slightly more complex, right? How do these secrets get updated, right? How do I do a database password rotation if there's DBAs and web applications and other services consuming that secret? How do I revoke a secret, right? So if it turns out that that thing has been compromised and I see, our credentials are now floating on the internet, or there's an active compromise situation, how do you revoke a credential that's in use, right? And then how do you start to do the mitigation, right? Do I understand when and where secrets were used? What do we do in the event of a compromise, right? What is our break glass procedure, right? So these are the kind of questions we'd like to have good answers to. Similarly, in data protection, there's a set of questions we might want to be able to answer, well, right? We'd like to be able to ask ourselves, is data encrypted in transit, right? So as data flows from our web server to our database on the wire, is that being encrypted, right? Or as it's flowing between a different set of services internally. When that data is ultimately stored at rest, whether that's in a database, in an object store, key value system, et cetera, is it encrypted at rest, right? So as we write it out to disk, is it encrypted? Does that data get transparently decrypted on access, right? So I think this is a really interesting and subtle question, right? There's oftentimes those little checkboxes for things like S3 buckets that's encrypt data at rest, but that encryption and decryption is transparent, right? We write data that's unencrypted and we read data ultimately that's unencrypted, right? There is encryption taking place, but it's done transparently. And so why that's important is it impacts the kind of next two questions, right? Which is who's allowed to access that data? And is that different than who's allowed to access storage? Maybe I have human operators, right? My developers, my DBAs, they need access to the system to be able to do maintenance and debugging and things like that. But they might not necessarily need access to customer-facing data, right? My DBA maybe doesn't need the social security number of my customers, right? So there's this kind of meta question of, does access to the system imply access to the data, right? And if the data is being transparently decrypted, then the answer is yes, right? If I have access to the database and it's transparently decrypting, then by definition, I have access to the data as well. Versus if that's not true, if I'm able to access the system and what I'm reading is encrypted data, then that doesn't actually imply that I have access to the data. There's a separate process by which I need to decrypt it, and I may or may not have access to that, even though I have access to the underlying system, right? Oops. So, within this context, the kind of guiding principle for how Vault solves these problems is a notion of identity brokering, right? So on one side, there's a set of systems that might provide us identity. These could be human-based identity, right? So it might be GitHub single sign-on, it might be my Active Directory credentials, might be a username and password that I as a human operator have. That maps to some notion of a human identity, right? This is Armon, he's a member of the development group, etc., right? At the same time, our applications similarly might have a different form of identity, right? They might be an EC2 VM that has a particular IAM role that defines it as an API server, or it might be a Kubernetes-based application that's tagged as being a database, right? So in that sense, there's these different identities that need to be threaded through from these underlying platforms, right? Whether they're human-centric or whether they're machine or application-centric, right? So what Vault does is integrate with all those different systems and bring it into Vault where you can apply a common set of policy, right? So I don't actually care if you authenticated via GitHub or Kubernetes or AWS. I can apply a consistent policy that says, great, web developers are able to get the database credential to do read access to the database, right? So in that sense, I can leverage multiple different identity systems for humans, some for machines, some for VMs, some for containers, right? But have a common way that I'm thinking about identity enforcement around that. And so then what Vault does on the other side is once we have this common notion of identity, Vault then has integrations into many different kind of runtime platforms, many different endpoint systems, right? Whether those are databases, cache systems, messaging middleware, cloud providers themselves, etc. So there's kind of a common way that we can broker access to all of these different systems, right? It doesn't matter if I'm giving access to a MySQL database or an Oracle database or an Amazon IAM key that lets me read and write from S3. I can kind of do all of that in a common way based on a common set of identity, right? So I don't need to have many different access paths, some for databases, some for message queues, some for cloud providers, right? It ends up being that Vault can act as sort of a single control plane for all of these different endpoints that we're accessing. And so when we talk about this kind of broad ecosystem, there's 20 plus different identity providers. Again, some of these human oriented, some of these machine and application oriented. There's 30 plus secret engines, right? And so a secret engine is an integration point between sort of an actual system that you want to give access to, things like MySQL, Mongo, cloud providers, etc. And Vault has support for all of the major sort of clouds and platforms that you would expect, right? All of the public clouds, major platforms like Kubernetes, Nomad, Cloud Foundry, etc. So now that was kind of a quick overview of Vault for folks that don't have as much background. Now I want to transition into some of the new announcements for Vault 1.4. And so there's kind of three categories that these will kind of fall into. We'll talk through each of these. One is an increase in sort of the ecosystem and broader set of integrations, right? So expanding the set of things Vault already can kind of speak with. Two is some big improvements in terms of how you can actually run Vault and operationalize it. Our goal, making it to be easier to run Vault and make it more reliable. And third is some improvements in the advanced data protection, really looking at how do you do this kind of more sophisticated data protection in systems that maybe are brownfield, where you don't have the luxury of doing rewrites. So when we talk about broader ecosystem, there's 6 different things I'd like to cover briefly, right? One is the Open LDAP secret engine. So Open LDAP is a very common distribution of LDAP, and it provides ways to provide sort of single sign-on experiences for users, right? So I can have a single username and password and use that across many different systems that integrate against LDAP, right? And so one of the kind of common use cases within an LDAP domain is a notion of service accounts. I might have a service account that is tied to an application. And so it's this long running thing that's not intended for a human to use, but it provides my application a sense of identity, right? And so one of the common challenges with service accounts is they're manually created, usernames and passwords have to be manually rotated, and it's hard to coordinate that across many different consumers potentially of that service account. So now Vault has native integration with Open LDAP, so we can actually automate the entire life cycle of that, right? So just to take a quick look of what that looks like. Historically, the path would have been something like this. We'd have a human operator interface directly with Open LDAP to either create or update a set of static credentials, right? So they create a service account for, let's say, a new service, create a set of credentials for that. And then they'd have to have a workflow where they go to Vault and update a static credential in Vault, right? This way, other consumers, whether it's applications or humans, when they need to know that credential, they just go and query Vault and it's there. Now, with this native integration, it actually enables a much more dynamic management experience. Instead, we do the one-time configuration of Vault. We provided sort of an initial set of credentials or sort of a bootstrap set of credentials. And from that point on, what Vault is able to do is actually own that service account with LDAP, right? So instead of every 90 days or 180 days having to manually go through a process of doing a rotation, updating Vault, notifying consumers, instead we do a one-time upfront config, say, great, here's the Open LDAP service account, here's the initial username and password the Vault needs to manage it. And from then on, Vault can do an automated rotation on a schedule. And that way there's less kind of ongoing overhead of maintaining that. The other one is it's similar integration for Kubernetes as, I'm sorry, not Kubernetes, MongoDB Atlas service. So MongoDB is the Atlas service is the cloud hosted Mongo. And so this gives you sort of a SaaS experience if you want a Mongo service, but at the same time, there's the same challenge of creating static credentials and needing to manually rotate those. So now that there's a native integration there, there's a similar option where you can do the one-time configuration of Vault. And from that point forward, Vault can manage the credentials for that Mongo cluster and do an automatic rotation by integrating directly with the Atlas API, right? So it can periodically connect with Atlas, do a rotation, and synchronize that with the clients that are consuming the credential, right? The next big one is Redshift database secret engine. Same sort of a concept. So if you're using Amazon Redshift as a data warehouse and brokering access to many different BI systems that potentially need to query data out of it, Vault can again do that central point of automatic rotation and provide that credential out to the different BI systems so that you don't have a complex manual update process, right? Now, there's a few others that are a little different in here that I wanted to mention. One of these is the Kubernetes service registration. So Vault has had Helm charts that allow you to easily deploy Vault onto a Kubernetes installation. You've always been able to do kind of label-based selectors to do service discovery within Kubernetes. But what this is actually adding is Vault now natively integrates with the Kubernetes API to dynamically update selectors as things change about the cluster. So as you seal or unseal your Vault, for example, that data will get annotated in terms of pod metadata so that you can actually say, I only want to route to an unsealed Vault instance, right? Or similarly, you might want to route only to the leader node or a primary replication site or secondary replication site, et cetera. So all of that type of metadata now gets synchronized with the Kubernetes API so that you can continue to use the label-based selectors to do service discovery, but you can get much more fine-grained. You're not just routing to the Vault service overall. You might want to route only to a primary instance or the active leader node, et cetera, right? The other two that I'll go into more detail in a second is the Kerberos auth method, as well as integrated storage. So the Kerberos auth method is an interesting one. So Kerberos is a very similar system to LDAP. Oftentimes they're used in conjunction. And the goal of Kerberos is to provide sort of a single sign-on experience. So I think where most users are familiar with this is with a Windows Active Directory environment, right? So in an Active Directory environment, a user does an authentication, right? So this might be when they sign into their workstation, they put in their username and password. That username and password is getting verified against Active Directory or Kerberos to verify the client's identity. And then what gets passed back to the client is effectively what's known as a session granting ticket, right? Or a ticket granting ticket. It's a ticket or token, if you want to think about it that way, that's a long-lived credential that identifies that user. That credential can then be used to generate sub-credentials that give that user access to different systems, right? The advantage of this approach is that for every new system that user is interfacing with, they're not forced to log in and provide their username and password again. They do a one-time login, upon logging into their desktop, and then Kerberos behind the scenes is minting these short-lived tokens that allow different services to authenticate that client and provide sort of a single sign-on experience, right? So now with the native Kerberos integration, clients that are already in a Kerberos environment or an Active Directory environment don't need a separate credential or a separate login flow to use Vault, right? Effectively, what happens is the user does their existing flow, right? Steps 1 and 2, which they would be doing anyway. They're logging into their workstation environment. they get their ticket. And then when they want to log into Vault, they basically provide a Kerberos provided ticket to Vault. Vault now has a native integration to go back and integrate with Kerberos and query to understand, what's the client's identity? Should they be authenticated? Is this ticket actually valid, right? And if so, great. Vault will then provide a Vault token, which is suitable for that client to interact with Vault and is bound to their their Kerberos identity, right? And so in this way, users can get a single sign-on experience and just extend the Kerberos support to their Vault environment as well. So now shifting gears a little bit, the second kind of big announcement was this notion of how do we improve the reliability and kind of the ability for people to operationalize Vault, right? And so the big change here is really talking about how Vault handles storage, right? So if you've used Vault before and you're familiar with it, the way it worked prior to 1.4 is Vault always depended on storage, right? So a classic deployment pattern for Vault would be you have, let's say, a 3-node cluster of Vault, right? That's stateless effectively. And so you have 3 nodes. One is a leader node. The other 2 are there in case a node fails to be able to take over operation. And then you have a separate cluster or set of nodes that are providing storage, right? So console might be used. You typically run either 3 nodes of console or 5 nodes of cluster console for similar reasons, right? So this way, if 1 node dies out of the 3-node cluster, it continues to operate, or 2 nodes out of a 5-node cluster. And so the challenge with this is it led to a much higher sort of basic infrastructure requirement, right? Just to deploy your 3-node Vault cluster, you also needed either a 3-node console cluster, or you were bringing an RDBMS system, MySQL or Postgres, or you had to use a cloud blob store, etc. Right? You needed some external dependency for Vault to be able to manage its data at rest. And so now with integrated storage, what changes is we're basically bringing in the storage requirement and internalizing that to Vault. So this is an optional mode. You can continue to run Vault in the mode that it's run up to this point. But for new Vault clusters, instead of running 2 layers of infrastructure, one just for Vault, one for its storage, you can actually just combine that into the set of Vault nodes. So now you can run 3 Vault nodes internally. They're now managing the data replication and the leader election among themselves. So how this actually works underneath the hood is we've basically brought in the Raft dependency, or the Raft library that's used in both the HashiCorp console project as well as the HashiCorp Nomad project, which provides both leader election and data replication and ensures there's sort of consistency of data and high availability of data across these nodes. And that's been brought in as an optional component of Vault. So if you configure Vault with its internal storage, effectively the Raft subsystem will be there and replicate data between these nodes, ensuring consistency and providing leader election, right? So our goal is the getting started experience should get much easier. No external dependencies are needed. You can just get started with Vault on its own, and it's fully contained binary at this point. And the next sort of set of features that falls in that kind of advanced data protection category, right? And so this really speaks to a set of enterprise set of functionality that we're introducing here, right? So there's a few different enterprise pieces of functionality that I want to cover. Some of this stuff goes back to that notion of improving the operations and kind of the usability of the system. So for things like disaster recovery, there's a simplified workflow in terms of how you'd promote a secondary site and the access tokens that you need to be able to have access to the system should you lose your primary. There's better integrations now. So for NetApp Enterprise, we support using Vault as a key management as the backend for that, as well as Vault Enterprise can be deployed through the Helm charts officially as well, right? The other big one is the transformation secret engine, right? So, as a quick review, many of you who've used Vault before or familiar with it might be aware of the transit secret engine. Transit has been a part of Vault for quite some time now. And the idea behind transit is it goes back to that notion of the difference between secret and sensitive data. Vault is designed to be able to store secret data, right? So you can put hundreds of thousands or a million records in Vault, and that order of magnitude is something that it's designed for. Once you start to talk about billions or trillions of records, that's an order of magnitude that Vault's not designed for, right? So it's a different approach needs to be taken. And so the idea behind transit was instead of storing data, what you do is you'd only use Vault in transit, right? So if I have a web application that needs to store credit card numbers as an example, it might flow that through Vault and use the transit engine to do encryption of that data, right? So transit will hold on to a set of encryption keys. It'll expose a set of cryptographic operations, encrypt, decrypt, sign, verify, etc. And so all of those operations don't require holding onto the data. Instead, the plain text data or the ciphertext data simply flows through Vault in transit. And then the end application is responsible for integration with a different database. So in this type of an example, the credit card flows into Transit, Transit encrypts it, and what comes back is an encrypted ciphertext, right? And then that is handed to the application. The application can then store that in a traditional database or key value store, object store, et cetera, whatever scale out store is being used, right? So there's many good solutions for doing scale out storage if you need to have billions or trillions of records. That's not a problem Vault is attempting to solve. So this was kind of the classic approach for Vault. Now, the challenge was, what if I'm in an environment where I can't accept a ciphertext that looks different than the input, right? So it's just a brief review. If you look here, you'll notice the credit card number, right, is just a set of numbers separated by hyphens. What Vault will return, there's no, is on purpose just an encrypted blob, right? It's an encrypted blob that in this case has been base 64 encoded to make it sort of more displayable, but it doesn't have any resemblance to the input, right? It's not the same length necessarily. It's not the same alphabet of characters. There's no real, mapping. And so the challenge in that becomes, what if I have a brownfield system and I might have a database, for example, that defines a schema where I can only accept, so many 18 digits, right? Or I only accept it as a number, and I'm removing the hyphens for storage, right? And so in a system like that, if I just try and use Transit in place, I'm either going to get a data validation error, or the system will, refuse to store the data. So it makes the integration a bit more challenging. You're kind of forced to retool the database schema or the application or the data validation logic, right? So this is where the transform secret engine comes in. So this is a new addition that's coming as part of Vault 1.4 in the enterprise edition. And what this allows you to do is define a custom alphabet, right? So unlike transform, Transit, which it will just return it in a kind of a broader base 64 alphabet. Here we can say I actually only want to get it back in this sort of numerical alphabet. I only want a certain length bound output. And so what I can start to do is match my input and output to make sure I'm not going to run into those problems, right? So that I can either fit into an existing database schema, or I can fit into the constraints of an input validation, right? And so similar to Transit, the goal of transform is not to hold on to data. It's not going to store, billions of records. But as data flows through it, the application can leverage Vault as a middleware to protect that data before it's stored at rest. The other kind of use case for this is data masking as well, right? So if we want to externalize some of that logic from our application, we can do the same thing, right? So we can say, hey, look for these patterns that are social security numbers or credit cards or email addresses, and allow Vault to automatically mask that data as it flows through it, right? So it's sort of masking data redaction, slightly different in the sense that it's not reversible, right? In the transform, use case, we want to be able to reverse that back to the original credit card or the original social security. Obviously, in a redaction use case, that's not going to be possible, but this might be useful for cases where we're exporting that data and we want to just make sure it's sensitized before it goes out. And so I'm super excited to share that Vault 1.4 is now generally available. You can download it and give it a spin, and feedback is always appreciated. And at this point, what I'd like to do is hand it over to Justin, and he's going to do a demo of some of these features. And as we kind of go along, if you have any questions, feel free to stage those, and then we'll do a Q&A at the end. Thanks. Justin, over to you.
Hey, so I'm running the enterprise version of Vault 1.4 here, and if you're interested in playing around with it, you can download it from releases.hashicorp.com. So by the way, I should probably explain what you're looking at here. So I have a split screen. In the top window, I'm going to be running most of my commands, and then in the bottom window here, I'm going to be running Vault server in dev mode. So let's fire that up. So if you're new to Vault, dev mode helps you quickly set up a pre-configured instance. This is basically meant for playing around and learning Vault. So you're given the unsealed key here and the root token as well. Also mentioned, it says, hey, don't run this in production as it's only meant for testing. I should also mention that for most of the demo here, I'm just going to be pasting commands and talking through them, since it doesn't really make sense for you to watch me type things out. So the first thing I want to do here is I want to configure the Vault address environment variable. This basically just says, as I'm running Vault commands, it knows what server to talk to. Second, I want to set up the root token. This basically allows you to pre-authenticate to an instance. And I'm using the token from down here. So I'm just going to hit enter in the bottom panel here so that we can sort of see the tail of the logs as they come by. The reason I do this is just, if I run into an error or something like that, at least I can see the logs and I can hopefully get pointed in the right direction. All right, so let's run Vault status just to make sure that we're connected to Vault and everything is as we expect. Great, so it looks like it's initialized and we're running the enterprise version. All right, so the setup's done. Let's dive in. So the first command we're going to run here is Vault secrets enable transform. This basically loads the transform secret engine so we can interact with it. You can also see in the bottom here it says it was successfully loaded. All right, so next we're going to create a transformation role for a payment card number. Say, for example, that you wanted to protect sensitive data around credit cards or maybe driver's license numbers or something like that. Next, we're going to create a transformation for this card number. Basically, it says, hey, how do we want to interact with it and what do we want to do with it? So we're saying, hey, I want to use this type of algorithm. I want to use this type of template. I'll talk about that more in a minute, but we have a bunch of built-in templates that recognize various patterns of card numbers. Say, for example, like a passport number, a credit card number, a driver's license number, those kind of things, any sort of PII data. You can obviously create your own via regex too. Then we're saying, hey, where do we want to get the block cipher source data from? Here we're saying, hey, assign this card number transformation over to the payments role. All right, so that's pretty much it in terms of setup. These are sort of one-time things that you'll do when you're first getting started with Transform. Say, for example, you'll say, hey, you know what, we have this type of PII data that we want to start processing. We want to make sure we secure credit card numbers or passport numbers or something like that. So you'll go through and define your various transformations, and then you can start pumping data through them. All right, so let's look at what that would look like. So what this command is doing is we're saying, hey, take this example credit card number, pass it over to the transform secret engine. I want you to encode it based on the criteria I gave you in the previous step. So let me just hit enter here and then we'll talk about it. All right, so you can see we have this encoded value here. What's sort of unique here is that this encoded value has the same structure and character set as the example credit card that we passed in. So you might be thinking, okay, why does that matter? Well, say for example that you're an online retailer and you have a large database of credit card transactions. And you could go through an audit and someone says, hey, you know what? These are in plain text. If someone broke in and dumped your database, they'd have all your records. And so you start looking around for solutions to protect this data. What's kind of cool about this is that this transform engine gives you the ability to encrypt values in place without changing, say, a database schema or going through a complex, re-architecture of your application. It's this simplicity here of just saying, hey, take this value and encode it and give me the same structure and character set back is sort of the secret sauce that makes the transform engine work. And as you can see, it's just super simple. So let's decode that encrypted credit card number here and see what happens. What we're doing here is basically running the process in reverse. We're saying, hey, decode this encoded value and give me the original credit card number back. I should probably mention that you're not limited to this particular structure or pattern here. You have the ability to write whatever kind of transformations that you want. Say, for example, in the encoded ciphertext here, you just didn't want numbers. Maybe you wanted alphanumeric numbers or something like that. You have complete flexibility to define it however you want. So the second example I wanted to chat about here is something called data masking. Armon chatted about it too. So basically, we're going to say, hey, I have a phone number, but I want to redact it or sanitize it in some way. So this command here is creating a new transform role for phone numbers. And then I'm just going to paste another command here that'll define a template. So we're saying, hey, I want to use this phone number template. I want to do a regex match for this pattern. So we're going to match a country code, an area code, and then the phone number. And then we're going to use the built-in alphabet of just numbers. All right, then this command is saying, hey, I want to use that phone number template for this transformation. So we're defining the algorithm as masking. We're defining the template. We're saying, hey, we want to mask the characters like this. Then we're assigning it over to the phone number. Again, these are just one-time steps. Once you figure out, hey, the type of data you're going to be working with, you can just pre-configure these. All right, so let's do some data masking. So we're going to say, hey, let's write some data into the transform secret engine. We want to encode it with our phone number template. So we're going to say, hey, here's the value we want to redact, which is a phone number. And then I want to use this transformation phone number. So if we hit enter here, you can basically see, hey, the encoded value is just a bunch of pound signs. So you might be thinking, hey, why is this useful? Well, say for example, you have a customer portal where you're asking a particular customer to verify their credit card number and you only want to show the last four digits. Or maybe you're sending a SMS message and you only want to show the last four digits of their phone number. Or maybe you have a much larger use case where you say, we have a big record set and we want to send it over to someone for data analytics. But we want to make sure that all the social insurance numbers in this record set are masked or, redacted. There's lots of different use cases where this type of tool could be useful. I should mention that on the Vault backend, we're not actually storing any data. So you pass us this, we redact it, and you get it back. If you're running a Vault cluster in your data center, you have complete control. You're not sending this private information out somewhere else. All right, so that's a transformation secret engine. I know we walked through it pretty quickly, but if you're looking for more details about it, make sure you check out the blog post we just posted. It walks through a bunch of use cases and it links to a bunch of additional documentation like learn guides where you can go through this step by step on your own. So for the next demo here, I was thinking we should probably highlight the Helm chart and also chat about integrated storage. And then I was thinking, hey, you know what? Why don't we highlight integrated storage running via the Helm chart? So basically, we'll fire up a Kubernetes cluster. We'll use the Helm chart to start a Vault cluster. And then we'll make sure those instances are backed using the new integrated storage feature. So let's have a look at that. So we've had the Vault Helm chart for a while, and it's been continually getting improvements. But as of Vault 1.4, we're releasing enterprise support. So in the top panel here, let me just run kubectl get nodes, and you can see I'm running a 3-node cluster. And then something I like to do when I'm working on this type of stuff is in the bottom panel here, I'll run the watch command running the kubectl get pods command. This basically will show you the state of the cluster as we work through the demo here. So I've downloaded the Helm chart already, but what I was thinking of doing is just showing you what dev mode looks like when you install the Helm chart. So you just set this dev mode flag here, and then we'll hit enter, and away we go. And then you can see in the bottom panel here, we have a Vault cluster, and then this Vault agent. This injector here basically allows you to inject Kubernetes secrets via a sidecar into applications that have no native knowledge about Vault. So how it works is it sources secrets from Vault, and it injects them into your application's file system so that they can take advantage of it. We have a whole blog and video and a lot of docs on it too, if you're interested in that. Again, I'm just going to be pasting commands so we can go quickly here. So I'm just going to run kubectl and we'll get the Vault status. And great, you can see Vault's initialized and it's not sealed. This is because we're running in dev mode again. Dev mode is kind of cool, especially on Kubernetes, because you can sort of play around with things and see how it works. You can see we're also not running in HA mode. So I'm just going to delete this dev cluster. And then we'll move over to playing around with integrated storage. So for the demo here, the intent is that we're going to create a Vault cluster hosted on Kubernetes that we'll install via the Helm chart. And, it'll take advantage of this new integrated storage feature. So for me, one of the main advantages of the Helm chart is that you can get up and running in no time, as you'll see in a second here. So when it comes to integrated storage, I guess it's sort of a personal opinion in that I come from an operations background. And when I see a tool that has integrated storage built right in, that's highly available and can tolerate node failures, it's just an awesome feature and I'm pretty excited about it. So let's walk through how it works. So the command we're running here is helm install vault. We're saying, hey, turn on HA mode. This will start multiple Vault servers. And then we're saying turn on RAF storage. This is the integrated storage feature. So after I run the command here, we're going to start multiple Vault servers. And then what we're going to do is walk through it step by step, manually configuring a highly available integrated storage cluster. All right, so let's get started. So you can see in the bottom panel here, we have our 3 Vault servers and they're coming up. We also have the Vault injector. Even though we're not using it, it comes up. This is configurable in the Helm chart. What's going to happen is you should start to see these flip over to running one by one. However, one thing that's going to happen here is that they're not going to come into a ready state. And that's because they're not initialized and they're not unsealed. So what we're going to have to do is manually go through and sort of boot this cluster up. So once they all flip over to the running state here, we'll walk through that. Great, so it looks like everything's up and running now. So the next command I'm going to copy over is basically going to exec into the first Vault node, and we're going to run Vault operator init. That's going to initialize our cluster. So we'll see a unseal key and a root token. similar to what we saw in a dev cluster, but that was already pre-configured for us. Great, so you can see the unseal key and the root key here. And then what I'm going to do is just copy the unseal key and the root token here, because we're going to use these in a bunch of commands. So the next command that I need to run here is I want to unseal the first vault node. That's basically going to turn it into a ready state. The sort of high level intention here is that we're going to basically boot up all these various vault nodes, and then we're going to join them into a highly available integrated storage cluster. So I'm just going to unseal the first node here, and you can see, hey, you know what? It's initialized and it's not sealed anymore. Great. Then I'm just going to clear the screen here, and then I'm going to log into the first vault node with our root token that I copied over. Great. That basically just gives us access so that we can run commands on the first node here. So the first command we're going to run here is vault operator raft list peers. What this command does is it says, hey, tell me about any integrated storage servers you know about. We're only going to expect one server here because we haven't actually joined Vault 1 and Vault 2 to the cluster yet. So as you can see, we have one Vault server and it's the leader. So the intent of what we're going to do here is log into the other two Vault nodes, and we're going to say, hey, I want you to join this integrated storage cluster. So let's run that command on Vault 1. So we're saying Vault operator raft join, and then we're saying, hey, here's the integrated storage cluster I want you to join. And then let's go ahead and run the unseal command against that too. And then down in the bottom window, you should see this Vault server flip over to the ready state. So let's do that on the third server too. So we're going to run the Vault operator raft join command, and then we're going to unseal it. And you should also see that one flip over. Great. So let's run that Vault operator command again to list its peers, and we should see 3 servers in here. So we see the leader and 2 followers. Great, so what this means is that we have a highly available Vault cluster running in Kubernetes via the Helm chart, and now we have integrated storage as well. So let's just run Vault status here. So you can see, yep, we have a highly available cluster, and it's in active mode. We just have a couple minutes left, but what I wanted to do is show you that this integrated storage actually works. So what I wanted to do is enable a secrets engine, and we're just going to store a couple key value pairs. So I'm going to turn the secret engine on here. So the next command here, I'm just going to save a key value pair. Say, for example, you have a web app that's sending email or something like that, and you need an API key. This might be an example of that. All right, so save that. Then the next command we're going to run here is basically just going to list the secret. All right, so yep, we were able to store the secret, and then we're able to retrieve it. So that's all happening on the Vault-0 server. So I'm just going to paste the command to log into the Vault 2 server here. Basically, the idea is, yeah, we stored some data on the Vault 0 server, and then I'm going to retrieve it on the Vault 2 server. So let's go ahead and grab that value from the Vault 2 server. Great, looks like we were able to grab the data. I know this is such a simple example, but it shows you that we have a highly available cluster and that integrated storage is working, and we're able to retrieve secrets from multiple nodes within that cluster. So let's just run that command again to list our peers in the integrated storage cluster. Great, so you can see we have our 3 nodes. One's a leader and 2 are followers. So what happens if we go ahead and delete one of the Vault servers? Say, for example, the leader. So I'm just going to run kubectl delete pod Vault 0, and you can see it's terminating that instance. So what's happening behind the scenes here is that our integrated storage cluster is saying, hey, one of the nodes in our highly available cluster failed. I want to elect a new leader that's going to lead this integrated storage cluster. Okay, so the instance died and it came back up. But let's see what happened in the cluster state here. So I'm going to connect to the Vault 2 server, and I'm going to run the command vault operator list raft peers. Great, so you can see that a new leader was elected, and it just so happens it was Vault 2. So what does this actually mean in practice? Well, that if you had a node failure, your cluster would survive, as well as the storage. So the first Vault node came back up. So to bring this Vault 0 node back online, we're just going to run the command to unseal it. In practice, I guess in reality, in a production environment, you're going to have a auto unseal happening. In that if a node fails, you'll have Vault authenticate against HSM or some sort of cloud-based HSM, and that node will automatically come back online. Then you'll have a true HA setup. in that if a node fails, you'll know it'll come back up. So that's it for my demos, but I just wanted to mention one thing. If you look over at the HashiCorp blog, we have an announcement blog, we have a blog on integrated storage, and we have a blog on the Transform Secret Engine. Those blogs are just loaded with content, what we covered today and plus way more. So if you're looking to get started with any of this, I definitely recommend checking those out. All right, thanks. I'm going to pass it over, and then I guess we'll start the QA session.
Great. Thanks, Justin. So we're getting a bunch of great questions in here. So we'll try to run through as many as we can. One of the ones that we're getting kind of more than not, so we'll kind of start there is, so Darshana, is there a migration plan and documentation for the integrated storage?
So yes, there is. So we actually have published a pre-flight checklist and a storage migration guide from console to integrated storage. We also have a bunch of other documentation as well as a reference architecture guide that is available that will truly help customers determine if integrated storage is the way to move forward and how to kind of go through that migration in a smooth manner.
Great, and we will also send out links and all of the blogs are available online, so we'll send those out afterwards. So Brian, what are the storage requirements for integrated storage, and does it require solid state drives?
Yes, so because all of the storage for integrated, all the data for integrated storage is stored on the local file system, we do recommend using an SSD, and that'll increase the throughput for write requests. We have an updated reference architecture that can be used with integrated storage, and we definitely recommend going and taking a look at that because in addition to SSDs, there's a number of other changes that we recommend for running integrated storage.
Great, thanks. So Justin, can we run open source Vault on Kubernetes, and do we need an enterprise license?
Hey, yes, you can run the open source Vault on Kubernetes. Actually, if you just go to Google and type, Vault Helm chart, we have a great blog with like a walkthrough video, and that should get you up and running. I should also point out in the demo there, I ran the integrated storage within the Helm chart, but you totally don't have to do that. I just was trying to sort of do two demos at once there, but you can run integrated storage totally on its own. So just in case anyone had that question there.
Great, and then Andy, there's a question on, it looks like it was, I think, transit, but if we're flowing billions of requests through Vault Transit, what kind of bandwidth requirements do we encounter? And are we now double dipping on network cost?
Yeah, so Vault Enterprise can already use existing functionality with Transit, such as the performance standby nodes and performance replication features, to be able to divide and conquer different types of transform, encode, and decode workflows. This optimizes both network and compute performance, such that the double dipping situation generally doesn't happen. Transform also has the same performance and compute requirements as or implications as the Transit Secret Engine does. So you can effectively achieve the same levels of performance that you can with Transit. Now, we've seen that reaching hundreds of thousands of RPS, so requests per second, without a significant network implication. Now, you need to configure Vault, again, using those other features to be able to run at that performance threshold. But yes, it's possible to run with very, very high level performance with the Transform Secret Engine.
Great, and Andy, since I have you, I'll ask another one in terms of transform. And when you do formatted preserving encryption, how do you know which key has been used for encryption?
Yeah, so that's a great question, and it highlights one of the interesting aspects about the Transform Secret Engine. In the Transform Secret Engine, when you use the FPE encoding method, because there's two types of transformations that we launch with. The first is a masking method that allows you to be able to mask the underlying data and anonymize it per however kind of format that you want to be able to anonymize. The second one with FPE allows you to encrypt data for encoding it such that you don't actually have to manage that key. So this isn't tokenization where, for example, you're hashing something and you have to manage like a hashed value, or you encrypt something and you have to like personally manage the key. Vault will automatically manage all the key material necessary for you to encode and decode that data. We talked about before, for example, that Vault is not storing data. It's true. We're not actually storing a copy of that data. What we're instead doing is we're storing the key material to be able to decode encoded data from Vault. So that process is fully automated for you.
Great, thanks, Andy. And then Brian, I will come back to you on another question. Since you are using Raft, can you have a voting only node?
Yes, so by default, nodes in the Raft cluster are voters. On Vault Enterprise, we offer the ability to mark a node as a non-voter. And this is particularly useful in conjunction with our other enterprise feature, which performance standby nodes. And so that allows you to scale the number of performance standby nodes up so you can continue to scale your read capabilities along with those nodes.
Great, and we're getting tons of great questions here. I know that we're pushing up towards the end, so if we don't end up answering all of them, we will send out the full list with answers written by the product team, product marketing, and so on and so forth. Let me see here. So Narayan, if you're available, is there documentation where all these commands for Kubernetes are mentioned? That would be helpful.
Yeah, that'll be part of the blog post, and we'll also have learn guides that will walk you through some of the demos that Justin walked through.
Great. And then there was one here, 1 second.
While you're pulling up that question, I might just add on to that. So if you go into the docs, especially around the Helm charts, there's a Kubernetes section, and then there's a Helm chart section where it talks out all the various config, and you can go into details on the various examples. So, if you want to run a dev cluster or a standalone or HA or Raft, all that's in there. So yeah, definitely check that out. It's sort of a goldmine there.
Great, and I think we can wrap up. So thank you everyone who has submitted questions. Feel free to submit more if you want before the end of this. And thank you to Armon and Justin for the great sessions and all the moderators on the questions. I hope everyone enjoyed today's webinar and you all have a better understanding of Vault 1.4 and enhanced capabilities. Please check out all the information that's live now in terms of the different blogs, learn, so on and so forth. For more webinars, you can visit our website at hashicorp.com/events. And then finally, as we mentioned at the beginning of this webinar was recorded, and we will make this recording, slides, and answers to the remaining Q&A available on our website after processing, typically within a day or two. We'll also send out an email to everyone who registered with the recording link. You can also keep an eye out on social for the recording. Have a great day, everyone, and thank you so much. Goodbye.